let's begin. We are still on double integrals. We are going to be looking at double integrals, but we're going to use a different coordinate system from Cartesian. So Cartesian is what we've been using last week. Essentially, you have your function and you're going to have a double integral over some region D. And you're going to have your function f of x, y. And then we have our dA. That's pretty much what it would look like. And you'd have a shape, and who knows what it would be. You know, it'd be a triangle perhaps. And this would be region D, right? And we would find the range either using type run, right, which would be vertical one. So actually in this case, it would make much more sense to do a horizontal one. And that's kind of what we did last time. So polar coordinate system is a different way to describe where something is in 2D space. So can you imagine a point P with coordinates x, y? That's Cartesian. If you imagine a line always from the origin going directly to P, then there are two numbers. One is called theta, which is the angle that the line, the red line, makes with the x-axis. And the other thing is called r, which is the distance from the origin to the point P. And when we can tell people, I don't know, I'm calling that Q, we could tell people where a point is using polar. So if I said to you it was 5,30 degrees, right? That would be polar, which might be what that is. Or if I told you it was 3,7, that would be Cartesian. So we're going to take double integrals that are going to start off looking like that. And are they back to using R's again? Oh, good. They're still calling them D's. I'm just wondering for a moment. How do I take an integral that is in terms of x's and y's in a region D and a dA and do it in polar? Well, in polar, it becomes a region over D. And it's not going to be f of x, y directly. X is going to be r cos theta, and y is going to be replaced by r sin theta. Back to this guy. The x coordinate is r cos theta, and the y coordinate is r sin theta. Can you see where that comes from? So the x's and the y's in your formula are going to become r cosine thetas for the x's and r sin thetas for the y. And this guy here is essentially dA. And there is an extra little r, which I forget a lot. That extra little r comes about because of the change of way of measuring it. It's basically just a leftover caused by what we would call a change in variable. So you do not know right now where that r comes from. Can you trust me when we do Jacobians that I'll prove to you where that r comes from? But right now you're just going to say, yep, for some reason, when you do polar, it's not just dr d theta, it's r times dr by theta. Also, when you're going to be doing these, turning your equations, you're going to be using some helpful little properties. Isn't x squared plus y squared going to be r squared? So if this function here was x squared plus y squared, I could just replace it by r, because these are going to be done. And another one, which is quite common and quite helpful, is that you might end up with some sine squareds plus cos squareds. And when that happens, isn't the answer going to be 1? Otherwise, you're just going to turn the x's using this and the y's using that. So what is the last piece of the puzzle? The region D is going to be a region. It's not a straight line. So let me show you some examples of D and what they look like. Imagine D was all the points in a circle of radius 3. Right. So this is region D. If you want to describe it in terms of r and theta, because you need to do that in these questions, r is going to go from 0 to 3, because basically that fills in all the inside. And you're going to start at 0 and you're going to finish at 2 pi. So that's what a complete circle of radius 3 would look like if you described it in terms of r and theta. Right, so it's every point inside as well. You almost always use polar when the region D is a circle or a bit of a circle. So let me show you a bit of a circle. Suppose I had this one and the radius was 2 and D was that region. R goes from 0 to 2. What would the range of values for theta be in this question? To generate just this half of the circle, what would theta be?
0 to pi.
Agreed. Now, just when you think you've got a hang of it, let me make your life really awkward and do this one. And let's say this is a circle of radius 5, and this is D. That's a 0, by the way. The R's don't typically cause problems. The thetas do. When you want to describe this half circle, you're basically going to start off with this angle, right? And then you're going to finish off with that angle. Now, I know where the finish is. The finish is up here, which is pi upon 2. What's less obvious is that. Now, you might say, why is that? Well, if you start here, aren't you going backwards, negative pi upon 2, and then you're curving all the way around to positive pi upon 2. Now, you might falsely write a different interval. A lot of people would just say, oh, that guy up there is pi upon 2, and that guy there is 3/2 pi. So pi upon 2 and 3/2 pi. That region is not him. Right? I know this angle is pi upon 2, and if you go the positive way around, I know this angle down here is pointing at 3/2 pi. But this region is not that guy. In fact, isn't this region that guy? That makes sense? Pi upon 2 to there. So this one works, that one doesn't. So far, so good. Right. Now you can get pieces of circles. They're probably a little bit easier to do, so I guess I should do one of them. A piece of pi, right? So, and my circle's going to look something like this. And let's say my circle is radius 10, and this is D. So R is going to be from 0 to 10. And I guess I should tell you what these angles are. So how about this is pi upon 3 on this side, and this is pi upon 3 on that side, just to be symmetric. Then theta will start at this angle, which is pi upon 3, and finish there. And this angle here is 2/3 pi. Are you comfortable about that one? That to get that piece of pi, the starting angle is pi upon 3, and the finishing angle is 2/3 pi. That value there is only to help you figure out what this one is. Any questions so far? Are we good? So D is going to be a piece of a circle of various kinds, or a whole circle. or it might be this guy. I'm quite pleased about that. That actually looks kind of what I wanted. This is 3, and this is 4. And for this region, we need to set up what the range in R and the range in theta are going to be. Right, so to get this donut shape, it's called a torus, if you want to know its fancy name. To get this donut shape, what would the range in R be?
Would it be 0 to 1?
No, but I know why you did it, because 4 take away 3 is 1, so 0 to 1. No, R doesn't need to start at 0. It does in all these shapes because, you know, 0 is part of the shape. But in this case, you don't actually start at 3. There's a code, or start at 0.
Is it going to be from 3 to 4?
It is. Does that make sense now? You see the answer. That if you take a random point on this region, just random point, won't its position, its R value, be somewhere between 3 and 4? Would you agree, no matter where you did it? Now, what about theta then? How about range of theta?
From 0 to 2 pi?
Yeah. Would you agree this shape goes 1 revolution? Now, if it had been only this piece, wouldn't we do negative pi upon 2 to pi upon 2? If it had only been this piece, wouldn't we do 0 to pi? I guess if it was the bottom piece, wouldn't we do pi to 2 pi, right? But if it's a complete circle, you're going to get all 0 to 2 pi in the theta angle. So that was a little skill building exercise on how to generate the limits of integration for R and theta. So let's take a question and do it. So we're being asked to find a double integral of x squared y dA, so writing in the standard form, and they describe D as the top half of a disk, center of the origin, and radius 4. So top half of a disk means top half of a circle, and the radius is 4. So here is the region D. So the R values in this question are going to go from 0 to 4. The theta will go from 0 to pi. Are we comfortable that that's D? That makes sense for that particular half disk, half circle. Right, so you go over here, and since they're both numbers, it really doesn't matter who you want to go. So I'm going to go 0 to pi, and then I'm going to go R equals 0 to 4. So that's the limits integration. X squared is going to become R cosine theta squared. Y is going to be R sine theta. And the dA is going to become R. Remember that weird R. In this case, dr d theta. Are you comfortable about how we set up the rest of this double integral? X's squared, y's, and the dA. Right, x squared, y, and the dA. Now, a little bit of algebra before we get too caught up on, you know, what goes first and what goes second, kind of thing. That guy gets you R squared. That guy gets you another R. That guy gets you another R. So I make it that you're going to have R to the 4 when you're finished. I've got a cos squared and a sine, so I'm going to put the sine first because I think they look nicer there. And now I have a dr and a d theta. So do you see that R gets combined with any other R that's floating around? And we're now looking at this question. Is this a variable separable question? Can I separate this? Correct, Andy, you're nodding.
Does our sine theta not get squared? Oh, yeah, now I see, sorry.
Okay, not a problem. You know, I make mistakes. It's worth, you know, double checking on it. So I'm going to collect all the thetas and the d theta here. And I'm going to collect r equals 0 to r equals 4 here. I like variable separable questions because don't they just turn into two Calc 2 questions? Right, this one here is simply just a power rule. What method will I use to integrate sine theta cos squared theta?
The u
What
sub
method? I agree. And who is the u sub going to be?
cosine squared of theta. Well, just cosine of theta.
Well caught. Yeah. And ... right? You could finish that yourself. Now, if I had left this question and tried to do it as a dx dy, right? It could be done. Let me show you how you would tackle it and why you probably wouldn't choose to do it this way. So, same question, same region, right? Well, if I was going to do this shape, I need to know the equation of that. Well, that guy happens to be x squared plus y squared equals 16, right? I know that. If I rearrange that, it's the same thing as y equals positive square root of 6 minus x squared. Why positive? Because it's the top half of a circle, right? So we would be doing something like this. Vertical rectangles. That would give me an x value from -44. And then the y value from 0 on the small side to this ugly guy on the top side. So you would be doing the integral from x equals -4 to x equals +4, from y equals 0 to y equals the square root of 16 take away x squared y dy dx. Let's just pause on that for a minute. This is doable, right? Couldn't I integrate with respect to y? Couldn't I then plug in these guys and get a whole load of x's? And then couldn't I integrate with in terms of x's, and we would get, eventually we would get a reasonably nice answer. I think it would take you a lot longer, and it would certainly be a lot uglier. Would you agree those square roots don't? Well, in this case, it came out better than they could. But if that was a y cubed or a y squared or something, this would become really, really unmanageable, wouldn't it? Quite quickly. So in general, leaving any shape where D is a part of a circle, leaving them as X's and Y's tends to generate really ugly questions. For starters, you cannot separate that, right? You have to do it as two separate integrals. So time-wise, it's going to cause problems.
I have a quick question.
Mhm.
Is the reason that the x interval is -4 to 4 and the radius on the other one is from 0 to 4 because the radius is just 4?
Yes.
Okay.
Right. If you're not picking up what he's asking here, if you think of this in terms of a radius, radius is a positive number, right? And in this half shape, isn't the radius, the most it's going to be is 4. And when you get to the origin, it's 0. But in this case, the x values have two extremes, don't they? So, same region, evaluated in a different way. Let's look at the next one. This is question 6. We have a double integral over some region. No, they call it R again. I don't know. I'm going to stick to D. I don't see why they want to keep doing that. So, pain in the butt. There's the guy. And the region that we are interested in is it's in the first quadrant. Wow, there's a lot going on here. So we have a circle of radius 2. So that's that guy. It's in the first quadrant, right? So it's only in here. The line x equals 0 is this guy. And the line y equals x goes like this. And when you put the whole package together, you get this piece of cheese shape here. So it's a circle radius 2, center of the origin. It's in the first quadrant, which is here. It's bounded by x equals 0 and the line y equals x. I wouldn't even want to do that. I'm not even sure how to start leaving it in terms of x and y, because when you do your little vertical rectangles or your horizontal rectangles, none of them work, right? You go from different place to different place. So this is a prime candidate for doing polar. And pieces of circles work really well with polar. Now, in this shape here, the radius is 0 to 2, right? So if the radius is 2, unless there's a circle inside the circle, it's going to be that. Now, it looks like we're missing some information here. Don't we need a start and a finish angle? And it is in the picture. Even if it is kind of disguised, it is in the picture. So I'm going to be starting here, right on this green line. What angle is that? And the clue is the straight line is y equals x.
Is it pi/4?
Yes, it's 45 degrees, which is pi over 4. So I know I'm going to start at pi upon 4. Would you agree the finish angle's easy? Vertical upwards is pi upon 2. Are we good about that? Now, different scenario, at least a different angle. If the straight line is y equals a half x or 2x or 10x or a million x, whatever it might be, you can still find the angle. Theta is the inverse tan of the slope. So here's a little piece of information for you. Theta is the inverse tan of the slope. And in this case, the slope was a half. In this case, it's inverse tan of 1, which we know is pi upon 4, and it works. If you were doing this, you're going to have to deal with decimals. And this one's an exact value. So I have r equals 0 to r equals 2. I have theta equals pi upon 4 and theta equals pi upon 2. I have 2 times r cos theta. Take away r sine theta. And then remember that r dr d theta. In this case, switch the places. So I'm going to have r equals 0 to r equals 2. The angle is going to be from pi upon 4 to pi upon 2. If you multiply this whole thing out, actually I got a better way to do it. I'm going to pull out r as a common factor. If I do it that way, I actually get some benefit. By pulling out r as a common factor and then multiplying that with the other r, we now get this expression. And that separates. And then calc 2, and you're done. Are we good? Trying to do this question in X and Y is just a non-starter. There's no way you can do a vertical or a horizontal. that is going to match that shape the way it needs to be matched. Let's do, as our next one, 8. And we're told that the region is in the first quadrant and it's between two circles. One is radius 1 and one is radius 5. So the first quadrant means here, right? Just in here. And it's one with a radius of 5 and the other one has a radius of 1, even if that's not to scale. There is region D. Any volunteers for either the range in R or the range in theta for this guy? Oops. Any ideas?
The range of R is from 1 to 5. And
Great.
theta should be from 0 to pi over 2.
Does that make sense, everyone? 0 to 5, 1 to 5, I should say, I almost said 0 again. Put in 1 to 5, and then starting at 0 and finishing at pi upon 2. This fella just becomes the sine of R squared. Remember that little list, where is it? That if you ever see x squared plus y squared, it simplifies down eventually to r squared. And then you're going to do an r, dr, d theta. And actually I should switch order of those. You don't need to write this, I'm just rewriting this again because it's a mess. And it is separable. I'm not sure if we've ever seen one separate quite the way this one does. Well, that's the easy one. We've actually got a question that doesn't have any theta reference at all. So I guess the puzzle is, I need something here, right? I can't integrate a blank, right? I need something here. What would be reasonable to assume goes here?
Would it be 1?
Yes, would be 1. So if one of the two variables is not actually even present, you can still do a variable separable, right? But you can just do it as a 1. Now, in this case here, you integrate it, you get theta, and it would go from theta equals 0 to pi upon 2. And our go-to guy again, what would this one be? What method should we use to do this
U
one?
sub.
It's a U sub. Now, if I was writing this blinking question, I would have done this. It's the only difference. Now, if x squared plus y squared is r squared, if you ever see a square root of x squared plus y squared, wouldn't that just mean r? Right? So that question, if I was in charge of it, would have ended up being this fella. And if it had been this question, I know it's not, but if it had been this one, what method would I use this time? That's a U sub, and U equals R squared. Agreed. But what would this one be?
Integration by parts?
Yep, integration by parts. So I still haven't seen one, but I know they can exist. Maybe it's in the odd questions that I've not bothered to test. Let's do an odd one, just to be different then. This is question 9. We have a region the thing we're going to integrate looks quite weird. And D is described as the region bounded by the y-axis, which is that axis, and a guy that has got a really weird look to it. So we're bounded by the y-axis, which means that's going to be one edge of D. This is a disguised version of someone. Do you recognize what this is a disguised version of? What could that be rewritten as that would be more familiar to you?
X squared plus y squared equals 25.
Correct. So if you square both sides and you add a y squared to both sides, can you see it now? Now, we're looking at a circle of radius 5. So we've got that little boundary line here, which means I should be able to describe r and theta. R is going to go from 0 to 5. And we talked about this at the start of today. What are the range of thetas to make this shape happen?
Negative pi over 2 to pi over 2.
Are we comfortable about the negative thing, right? You have to start this side, call it negative, and then curve up to the other one. So we have a negative pi upon 2 to a positive pi upon 2, and r is going 0 and 5. We have e to this guy, and then we're going to have an r dr d theta. I guess the only thing left is, what about this negative x squared, negative y squared thing? That really needs to be written in terms of r and or theta. It's actually quite nice looking. It's connected to this answer, isn't it? So if x squared plus y squared is r squared, what would negative x squared, negative y squared be?
Negative r squared.
Okay, so we are going to deal with that guy. And the variables separate. I'm just not going to write them down. But, you know, I could put a 1, I guess I should. I've only done it once, so it might not be often enough for you to feel comfortable. Right, that's how you take care of the thetas. I'm getting fed up you asking this question, but I guess I really should, even although I know the answer and you should know it too. What method will I use to integrate this?
U sub
Who's the u sub going to be?
negative r squared.
Or r squared if you want, doesn't matter. Are we good?
I have a quick question. How did you know to put the radius first this time in the integral?
Didn't. I could have wrote it the other way around. I just
Okay, so it doesn't
decided-
matter?
Just, yeah, because they're both numbers, it doesn't matter.
Okay,
If one of them had a, you know, if it was from r equals 0 to r equals theta, then that would have decided that the numbers should always go at the end. If both of them are numbers, it doesn't matter. But if one of them is numbers and the other is like r equals theta and r equals, you know, something else, then you would have to put the r here because you need numbers on the outsides. Now, the next one we've got is a really messy, ugly, try to think of other words, verbs. Ugly I'll do. We want to do an X dA. Nothing bad can happen here. D is in the first quadrant. That's the first thing they told us. It's between x squared plus y squared equals 4, which is the circle radius 2, and the ugly bit. X squared plus y squared equals 2x. That is not going to be our friend. I can tell you right now, that is not going to be our friend. We need to figure out how to describe this quite messy region using nothing but r's and thetas. I'm cheating a little bit because I don't want to use Esmos, so I went and got the thing to tell me what the shape looks like. Right, we know it's in the first quadrant. If you do this circle, oops, that's a 2. That's -2. And then this guy here is not clear what the heck this guy here is. But if I rearrange it, and then I complete the square, you get that. So it's a circle, center 1, 0 with a radius of 1, which ends up being that guy. So our region D is that guy. Big problem. We need to find the limits in terms of r and theta. Now, when it's a nice normal circle, or a bit of a circle, it's really just r is between this number and that number, and theta is between this number and that number. All bets are off right now, because essentially what we need to do is we need to figure out how to describe this region. And it's not a circle inside a circle in the usual way, right? Isn't this off-centered? So if you imagine me taking, green note, a random radial line, isn't the guy that we want an R value between here and here? And doesn't that R value change size depending on the angle theta, right? So I know it's a little bit messy. Let's get the easy one over with. If I wanted to describe this shape, wouldn't the radial line start at 0? And wouldn't the radial line finish at pi upon 2? That tells me at least I know that guy. So far, so good. Now, I need to basically find out what this guy looks like and what this guy looks like in terms of R equals. Right. So let's do the first one. I'll put the answer up here once I get it. If you look at x squared plus y squared equals 4, doesn't that just become r squared equals 4? And since we're using positive numbers, can't we do r equals 2? Are you comfortable about that guy just being all the points whose r value is 2? Right. So that's him. So I know, since he's the furthest away, that that guy is 2. Now, x squared plus y squared equals 2x. This guy becomes r squared, and this guy becomes 2r cosine theta. Are you comfortable with the replacement of x's and y's? Does that make sense? X squared plus y squared is this. That guy is that, right? Oh, by the way, if you're worried about this working, couldn't I've just plugged into Desmos and seen what it looked like? Right, back to this fella. I want R equals. I've got R squared equals 2R cosine theta. What could I do to find what R is equal to? And break a little rule that I'll explain why we can get away with breaking the little rule. What would we do to both sides to find R equals?
Would you divide by R?
Yes. Now, that is breaking a rule. If R was 0, wouldn't that be dividing both sides by 0? In this case, it's not going to happen because of the structure of it. So we now know that this side is 2 cosine theta. So we took each equation and found out what did they look like in terms of R. Big guy, little guy. Big guy, little guy. Has it lived up to this is ugly? Right. So now we can move over and we can say, okay, the limits of integration do matter. There's only one that has numbers in it. And there must always be one variable that has a start and finish in numbers. You can't do it with both. And the R is going to go from 2 cosine thetas and finish at 2. And the function is x, which is R cos theta. And since R is in the inside, we're going to do dr, and then we're going to do d theta. So in this case, the order was important. You see, we finished on the thetas the outside. I'm going to do a little bit of tidying up here. And we now have from R equals 2 cosine theta to R equals 2. And we have R squared cosine theta dr d theta. Is this function separable? Be careful. Is this function separable? Now remember, one of the rules about separable is don't all the limits of integration have to be nothing but numbers. Okay, you cannot separate unless everybody is a number. So I kind of answered my own question by saying that, right? So this is not going to separate, which means we're going to have to do it the old-fashioned one after the other way. With respect to R, you get 1/3 R cubed cosine theta evaluated at 2 cosine theta and at 2. If you plug in 2, you get 8/3 cosine theta. Take away 1/3 2 cosine theta cubed cosine theta d theta. You now get, just a little bit more tidying up, 8/3 cosine of theta. Take away 8/3 cosine of the fourth theta. Where are we going? How do I integrate that? Where are we going? Any ideas?
Well, you could take the -8/3 cosine theta to the fourth and turn that into like the cosine squared essentially.
Okay,
And then what you
yeah.
can do from there is take the cosine squared and turn it into the other thing.
Yes, you're right. I know what you're saying. I'll try and just write down the steps. What you said is exactly right, Matthew. Right. First thing is, won't you take care of that as a separate question, right? Just do that on its own. Now, this fella here is one that Matthew was describing. When you only have a single power and it's sine squared, sine to the fourth, cos squared, cos to the fourth. Nobody's going to ask you to do anything worse than that. In fact, I wish they hadn't asked you to do this one. I'm going to pull out the -8/3 just because it's a pain in the butt, right? So it's done. And now I've got cosine fourth, which I'm going to call that guy. Then what I'm going to do is I'm going to replace cos squared theta by 1/2. Can anybody remember? Double angle.
Is it 1 minus sine of 2 theta?
Down close. I'm running short of time here. Okay, I'm running short of paper here. Good grief, this thing's just growing like a monster. I mean, it's slowly but surely getting to a place where we can integrate. It's just not there yet. So that's the last guy that we had, right? This fella here. I'm going to pull out that half, and so I have -4/3. I've got the 0 to pi upon 2 guy going on. Essentially what I've now got is this guy squared. So if you've got this guy squared, you're going to get 1, take away 2 cosine of 2 thetas, and then you're left with a really messy cos squared 2 theta left over. That I can integrate, that I can integrate. This guy is going to be 1/2. I said 1 minus, it should be 1 plus, not biggie, got it. And this guy is going to be a 1/2, 1 plus cosine, a 2 times 2, so that's 4 theta, d theta. One plus 1/2 is 3/2. 2 cosine of 2 thetas plus 1/2 cosine of 4 theta d theta. Oh God in Himmel, can I just dot it because I broke the back of the thing now? And that is nowhere, even on a bad day, a nice question. That is a horrible question. I wish I hadn't given you it now that I've seen it. It looked much nicer when I was picking it. Okay, last name and bye-bye. I'll hang about for any questions. You're frantically writing, Maggie. Did you get it all? Can't hear you.
I think
Okay.
so.
Yes.
I do have a question.
Yes.
I think I just missed what you said. What happened to the first part, when you put the line in?
Yeah, I'm just saying integrate that on your own, right? Just do that as a separate integral. So that
Okay.
would get you 8/3 sine theta evaluated at these 2 points. I'm just wondering if this is an even function, in which case this horrible mess might actually just be 0 and I didn't need to do anything. What's the cosine of 2 theta? Is going to be the cosine of pi, isn't it? That's going to be 1 and -1. No, it's not. Okay, it's not 0. I was hoping it was an even function. I could just say answers, an odd function, I should say, and that the answer to that integral was just going to be 0. That would have been so much nicer. Now, it's, according to them, it's 1/16. 16 take away 3 pi. Bit amazed that it would be that, but evidently. Maybe I'm not amazed, because you're just finding the cosine at pi upon 2's and pi's and at zeros. So they're always going to come out as 1s and 0s and -1s. So I guess it does make sense that you just get various numbers that aren't particularly ugly. The integral's ugly, but the numbers are not. Are we good now? Dylan, do you have a question?
Yeah, if
Yeah.
you're short on time, we can do it tomorrow, but it's just the third question on the test from last week.
If I look at that,
It's the one with the box and finding the maximum volume.
okay, let me find your guy. And that was question 3 in the test. Let's have a look at that. Oh, you had a problem with that test, I
Do
can
you
see.
mind if I stay?
Sure, I won't show anyone what you got. I'll just go through the question. So in this question here, we have a box that looks something like this. Yeah, it's pretty much like about. And you have a distance here to here, which they're calling the length. And then you have another distance, which is basically walking around the outside of the shape, this red line. That total thing is called the girth. Yeah, okay. Now, suppose a package in the shape of a rectangular box can be made by a certain postal service if the sum of its length and girth, so I'll call that S for sum, I'll use the word sum, of its length plus its girth can be at most 96. So what you're telling me is that plus that, I should start putting in variables here. So how about X, Y, and Z? So the length is Z, because it's just that guy. And the girth is an X, a Y, another X, and another Y. So that's 2X plus 2Y. Okay. And you're being told that it is less than or equal to 96. Okay. And we are trying to find the largest volume. So the largest volume is X, Y, Z, right? That's the volume. So we're trying to maximize the volume subject to that constraint. So this is going to be my f of X, Y, Z. And this is going to be my constraint function in terms of X, Y, and Z. So the gradient of f is going to be lambda, the gradient of G. So the partial derivative with respect to X, Y, and Z is going to be lambda, the partial derivative of X, Y, and Z. Right, if you do a partial derivative of this function with respect to X, you get YZ. With respect to Y, you get XZ. And with respect to Z, you get XY. And you're going to have a lambda. And this guy with respect to X gets you 2. This guy with respect to Y gets you 2. And this guy with respect to Z gets you 1. So I need more room, so I'm going to do it over here. So if you take as your first equation the x components. YZ is 2 times lambda. If you do the second one, XZ is 2 times lambda. And the third equation is XY is 1 times lambda. Okay. Now, we'll make the assumption that lambda equals 0. And if I do that, I end up with basically, the only way that can happen is if everybody is 0. And if I take the point 0, 0, 0, it does satisfy the constraint. But what I've found is not the maximum value. Haven't I found the minimum value, which is basically the box ain't there. So like a dot in 3D space. So I'm not interested in that, but I did need to check it just in case. So what I'm going to do now is I'm going to take equation 1 and divide it by equation 2. So I'm going to do YZ over XZ, and that's going to be 2 lambda over 2 lambda. And a lot of cancelling here, and I get Y over X equals 1, which means that Y can be written as X. We'll a little cross multiply. Y
You
equals
only
X.
used 2 of those equations though?
Oh no, I'm going to use equation 1
Oh.
now and equation 3. And I'm going to get YZ over XY. And I'm going to get 2 lambda over lambda. And Y's cancel. I'm going to get Z over X is 2. And so Z is equal to 2X. And now I'm going to go to the constraint equation, which basically says that Z plus 2X plus 2Y, and I'll take the boundary because that's the biggest, is 96. And 2X for Z, 2X for 2X, and 2X for that guy. So I get 6X is 96, and I get X is 16. Now they want to know the dimensions, so they want to know what X is, okay? They also want to know what Y is. Well, Y is whatever X is, so it's 16. And they also want to know what Z is, which is twice what X is. So that is the dimensions of the biggest volume you will get out of that box. Make it a 16 by 16 by 32.